Tarfa. I am a math and science curriculum writer. I'll explain what I mean by both there in a second. And then I'm a medical physicist as well. Part of my training in medical physics involves studying the applications of physics in medicine and radiology and so on and so forth. So I use math every day as a professional, but I also use math. I study math because it's beautiful, not for its what's the word we use? Not for its practical use necessarily, but I think that math is beautiful inherently. That is important because for me, the limits of mathematical learning and exploration are not bound by any artificial expectations of society. Why? Because I think it's beautiful. And we see that from some of the greatest scientists of old. So at the end of my presentation, I'm going to be sharing with you some of the lessons I've learned in studying the history of science. Now, the reason why my background is math and STEM is because my bachelor's was actually chemistry, and then I got my master's in medical physics. But then I took a year of a PhD in physical chemistry, and that was where I found the most beautiful combination in the world, which is math, physics, and chemistry combined. And that is just so beautiful. So anyways, that is a little bit of my background. Today, I want to talk about 3 elements of a great math lesson. There's 3 main strands I want us to discuss. The first one is the logical, solid content that is necessary for an effective math classroom. That's number 1, and I'll come back to that in a second. The second is the importance of context, and the third is what students need. What do students need from their teachers to help them have the best math experience possible, right? How do teachers lead and guide their students to be the best they can be in their math and science journey? So let me just quickly break down each one of these, starting with the first one. I think that the logic. So this is the same from the first slide. So, and I'll send you PowerPoints if you want. But the first step, I think, in having an effective math classroom is having a logical, solid content framework. Like one of the things that I find interesting in our math classrooms around the world, or just in America, for example, is does anyone know what's going on? And I know that Stella Maris teachers know what's going on. But I'm just saying, in some math classrooms, it's almost like, where are we going? What is the goal? And does anyone know? Or are we just trying to patch up different things and there's no reason or no purpose for the things that the students are learning? Let me give you a practical example, and then I'll explain what these topics are. When you look at the state of education today with math education, the goal in one sense from the 1960s or 70s was actually to get as many students to calculus as possible. The reason for that was partly because of what Russia had done with the space race, and we were trying to catch up. And this is some of the facts that I've looked at through the years, is this idea that we made calculus the goal. Now, I love calculus, and I'm fine with that, with calculus being a goal. However, we have a lot of states in America where not even 5% of students take calculus. The average percent of students who take calculus in America is about 15 to 20%. The reason why that's important is because in Singapore and France and some other countries, that percent is 50%. Now, why this matters is we are teaching concepts to students sometimes, telling them that the reason they need the